Okay, we're back, and right now we're going to cover 7.2, which is the small sample estimation of the population mean. So to get into that, we have to talk about what a student's t-distribution is, because this is where the t-distribution table comes in. Before we were looking at the normal distribution table, and that was with respect to a z-score and large samples, but now we're going to talk about smaller samples. And in some cases with smaller samples, the student's t-distribution table comes into play. So what is the difference between a t-distribution? Well, it's very much like a standard normal distribution in that it's centered at 0, but it has the same qualitative bell shape, and it's a little bit heavier. So the tails are heavier than the standard normal table. So one formula that is very, very similar to the one that we already talked about. The first is, if a sample is small, which means it's less than 30, right? That's what a small sample is considered. If the standard deviation is known, we're using exactly what we did in the previous section, all right? And we actually did an example like that. I think it was the first example that you had. It was a small sample, but the standard deviation was known, and therefore we could use that same calculation method that we used before, using the normal table. But now where it varies is when it is unknown. So when the standard deviation is unknown and we're dealing with a very small sample, we now need to use this student t-distribution. So right now, do an example that will exemplify that. Okay, so this example right here that we're going to take a look at, obviously I have some notes on the top here, but it's kind of what we just covered. But notice that we have an example that represents a small collection, so n is less than 30, and the standard deviation of the sample is unknown. So we have the population standard deviation. Because of that, the formula that we want to use was also listed on the previous slide that we just looked at here. So it would be if sigma, or the standard deviation, is unknown, then we are going to use the mean plus or minus the t-distribution sub theta divided by 2 times the standard deviation divided by the square root of n. Okay? So for this particular example here, we can say that x, right, is going to be 12, right? And why don't we write it right under it? 12 plus or minus. And then over here, we need to figure out what this value is going to be. But at the end of the day, it's really t.01 because we are constructing a 98% confidence interval. We get that from 1 minus 0.98, which is going to equal 0.02. 0.02 divided by 2 is going to give us that 0.01, and we divide it by 2 because it's half. What we calculated here was alpha, okay? And then over here, we can simplify this by doing 1.2 divided by the square root of n, which is going to be square root of 25, which is 5. So in this next step here, remember this is still margin of error. Error is going to equal this calculation, and then we're going to figure out what our confidence interval will be. But right now what we're going to do is we're going to go to that t table, and then we'll come right back and fill this in. My apologies, but for t-distribution, one other piece that we need to cover here is that with a t-distribution, you need to figure out what the degrees of freedom are. And essentially, the degrees of freedom are simply n minus 1. So since our value of n is 25, then we can say that n minus 1, or 25 minus 1, degrees of freedom is going to be 24. So we have 24 degrees of freedom here. We're going to take this along with this piece, and we're going to bring it to our t-table to figure out what this value is. So in the same place on my courses where we found our standard normal table, we're now going to use our critical values of t-table. So if I click this PDF right here, what's going to come up is a critical values of t-table. And the way that we read this one is slightly different than the standard normal table. What we would do is we'd find our value of t, or our sub-value of t, which is 0.010 here, and then along the left we would look for our degrees of freedom. Since we're looking for 24 degrees of freedom, we have to go find that, so we're going to scroll down. Where's the 24 degrees of freedom? I find 24 right here, and then I need to go across and see what that 0.01 is, so 0.01, looking for 24, and when I do that, I get this value here, 2.492. And now we're going to slide right back to our notepad, and we're going to finish completing this problem. Okay, and as you see right here, we have our our margin of error. We plugged in our 2.429, which we found on the t distribution table. We simplify this right here. What we end up getting is 0.598. And then if we want to go ahead and figure out our confidence interval, we can do that. And when we do that, we subtract it from 12. We get 11.402. We add it to 12. We get 12.598. And what does this mean? Well, it says we can say with a 98% confidence, right? With 98% confidence that this small sample that has a standard deviation or a sample standard deviation that's unknown has a 98% confidence interval that it would fall, or confidence that it would fall in between these two values. That is the sample mean falling in between these two values here.